Transmutation. In 2017, we had some interesting results, but we weren't in a place to talk about it with confidence. Today we are. So this is before. This is during our plasma discharge. What's interesting about this is that the plasma double layers have collapsed down and become very intense around the anode, and now it's giving a uniform coronal glow. Just keep this in mind as we go through this presentation. And this is after. And we said, well, that's interesting. We had other words. So we decided it was time to subject it to what's called scanning electron microscopy and EDAX. They kind of go hand in hand. Technology's been around for 30 years, and scanning electron microscopy is just a very powerful microscope. EDAX basically is technology where they energize the elements that are on the sample, and they can tell you definitively what those elements are. And they use it for forensic sciences, all kinds of things. And it's a standard piece of equipment. It's about $1 million for one. I wouldn't say it's standard or common, but it's very good. So this is June in another lab that we work with, and what we did with the sample. So when you go over a sample like this in a scanning electron microscope, it's almost like scanning over top of a planetary surface. So just imagine that you're in a satellite or a rocket, and you're saying, well, that's interesting. So pretend you're in there. We're zooming in with the microscope. And things get interesting. And then we said, what are you doing there? A ball. And then you can get into all kinds of discussions about how a sphere can form in an experiment like this. And there's a lot of people that agree that to get a sphere like this has to form in a non-gravitational environment. So if you want to make spheres, you throw particles up that are heated, and as they glide through the atmosphere, they become spherical. We don't know what it was. We didn't know why it was there. There's better pictures of this, but just take a look at some. There's some almost like tectonic thing happening here. We can't tell you some of the things that we did to get there, but we can show you the results. So if you see some of the elements missing, that's some of the elements that we can't discuss. But what's interesting is these elements that you see were not in the chamber before. And sapphire is making lanthanum, and it's making cerium, it's making carbon, and it's making oxygen. So we went and scanned another region. He said, well, that's interesting. That doesn't look like the base materials at all. And this is what we found. We found phosphorus and silicon and titanium and oxygen and magnesium and calcium and sodium and potassium and aluminum and carbon and chlorine and sulfur. Those were also not, and we know definitively they were not in there. What you see here in the previous slide is that these formations are actually growing out of the surface. It's growing. That's what they look like. This looks like actually a fish egg sac full of particles and things. So he said, well, nobody's going to believe us because, well, we're the Sapphire team, and of course we're completely biased. That's how they're going to see it. So he said, this particular agency said, we have a lab for you if you want to validate your results and send it down to this lab. And it's a lab that they use and Lockheed uses and others. And we said, okay, we want you to go and scan the sample and tell us what you find. And this is what they found. And I thought, wow, that's a really interesting ball into what is going on there. It's like these particles forming in here. And they confirmed the fact that the predominant elements of that ball are cerium and lanthanum. These are heavy elements. And they scanned another area, and they came up with titanium, chromium, zinc, phosphorus, and carbon. What we did is, because our EDAX machine isn't as good as theirs, they have a bigger budget, they can resolve for carbon and some of the lighter elements, and they sold us some of the predominant elements there. In fact, sapphire is making carbon. Zinc is not there, and neither is the phosphorus. So this is some of the things that it's making, but there's even more coming. What's interesting is the topography, and this is as close as we're going to get. This is basically, you might say, it doesn't look like crystals, but In metallurgy, you use the word crystalline structure. You can see how the top surface of the main nodules in the material have been eroded. What's also interesting is the vent holes that are here in this material. So we said, well, that's interesting. Let's go and take a look down in between these mountains or these guys. And we found other things like calcium and chlorine and carbon and potassium. And these are certified materials. So we got them from a certified company, certified spectroscopy done on the materials before we actually put it in the chamber. So we want to make sure we're doing good science before we start making claims like this, especially these kinds of claims. We start with a periodic table of elements, and we're using the word catalyst because we can't think of a better term to use for the types of gas constituent or composition and the materials that we have that the anode is being exposed to. So we're just saying these are catalysts. We introduce those into the chamber, and when we fire it up, that nice bright anode that you saw that looks like a sun, this is what it returned. These are the new elements, minus the catalyst. The aluminum and silica we wrote off because, well, our probe, it's alumina. So we figure, well, maybe it's some contamination. Maybe making it, may not be, but we're just going to say, look, let's just dismiss it. But you have a pile more that Sapphire's making. Now, what's cool about this is that we can repeat the experiment. Okay? And get the same results. And we've dialed it up and we've dialed it down. And we can, it's tuned. That's why when Wal was talking about, good technology, bringing to bear modern technology that Birkeland didn't have, well, this is what modern technology can bring us. It can bring us some answers, or actually maybe more questions.